Hello again. Yes, it's me, and I'm here with your Week 10 MyStatLab Problem 9 example. Many companies outsource segments of their business to external providers, such as information technology and human resources. The data below show the types of outsourcing decisions made by a sample of companies from two industry sectors. Our data is down here a little ways. We'll get to that in a minute. Let's go ahead and look at part A of our problem, which asks us to select the appropriate procedure. So we're looking at goodness of fit, and that compares the observed distribution of a single categorical variable to an expected distribution based on a theory or model. Test of homogeneity compare the distribution of several groups from the same categorical variable, and test of independence examine counts from a single group for evidence of an association between two categorical variables. Well, to test difference in outsourcing by industry sector, there's one group in the data, the companies, and there are two categorical variables, the industry sector and the type of outsourcing decision. All right, since there is one group and two categorical variables, this tells us the chi-square test of independence is what we need to be using. Part B asks us to check the assumptions. So in order to use a chi-square test of independence, the data must be counts for the categories of two categorical variables. The data must be independent or from a random sample, and the sample must be large enough. All right, in this case, our cells must each have more than 5 in them. The data consists of counts of the number of companies in each sector that made each type of outsourcing decision. So there's no reason to believe that the outsourcing decision of one company depends on the outsourcing decision of another, or that the sample is not random. So it looks like we're good to go. So now let's look at our data that we were given. We need to first find the expected values, and to do that we need totals. So let's go ahead and sum up our rows and our columns. And we'll see if we can copy and paste this across here. And there we have it. So there are the totals for our data that we had. So next we need to go ahead and find our expected values. And you know from your reading and from other videos that we've done that in order to find that, the expected value of each column is going to be, in row, is going to be the row total times the column total divided by the grand total. So let's go ahead and start with that. So we'll let Excel do it, equals our row total times our column total divided by grand total. And there we have our first one. So we can go ahead and do this all the way across. Equals the row total divided by column total. Excuse me, that's times the total column. The column divided by our grand total. There we have there, one more time here, equals row times column divided by grand. Move on here, equals this row times column divided by grand. And we'll do that a couple more times. And then we can go ahead and add them up to make sure we're good there. Same as the one above. Same as the one above. sum those, and now we can sum across the bottom. And there we have it. Everything is good. So there are our expected values. So next, let's move on to part C. And let's state our hypothesis. In chi-squared test of independence, the null hypothesis is that the categorical variables are independent. So for us, outsourcing is independent of industry sector. Therefore, our null hypothesis, our alternative hypothesis will be there is an association between outsourcing and industry sector. So there are our hypotheses. Let's move on to part D. Now we are to test the appropriate hypothesis at the significance level of 0.5 and state our results. Well, the first thing we need is our chi-square test statistic. And we've done this before in some of our videos, and we'll do it again here. Our formula is the same as we've used, which is the observed data minus our expected data, and we'll square that difference, and then we'll divide by the expected data. So let's go ahead and look at that. And we're going to say equals, and I'm going to use parentheses here to take my observed minus my expected for financial IT only. I'll close those parentheses. And of course we need to square that. And then we're going to divide by our expected, again, which was here, IT in financial. Enter that, and there we have our first value. Now I believe I can copy and paste these and not have to do the whole thing over and over again. So let's go Command C here, Command V one more time. There we have it. You can see I had my formula already over here to sum all of our data. You can highlight it all and sum. I'll click on it here and show you my formula, that the sum of all of my columns, and that gave me the chi-square test statistic at 4.296. Now we need our p-value so that we can finish up our problem. And for this, I'm going to bring up another link to a calculator that I found. I did that in an earlier one in this week's MyStatLab homework problems. Let's take a look at one here. I'll bring it up, and I'm going to put this link. It's already on the page here for my video. I'm also going to put it on when I post my link, so you'll have that one also. And it asks us for the chi-square value and the degrees of freedom. Well, wait a minute. What are our degrees of freedom? How do we calculate that? Does anybody remember how to do that? We know it's the row minus 1 times the columns minus 1. Well, we have 2 rows, so 2 minus 1 is 1. We have 3 columns, so 3 minus 1 is 2. So 1 times 2 is 2. So our degrees of freedom in this case is going to be equal to 2. So there we have that. So with our chi-square at 4.296 and degrees of freedom of 2, let's go back to our calculator. And everybody remember for me, 4.296. All right, remember what it was? 4.296 with our degrees of freedom of 2. And let's calculate. And there's our p-value, 0.1167. That's all we need, 0.1167. So there we have it. So now we have our chi-square. We know our degrees of freedom were 2, so we could calculate that. Now we have our p-value, which we can compare to our alpha, which was 0.05, and in this case our p-value is greater than our 0.5 alpha, so you know what that means, right? We are not going to reject our null hypothesis in this case because our p-value is greater than our 0.05 alpha. Well, there you have it. Excel did a lot of work, took a little bit of time, but that's okay. We got through the problem there. We got all the information we needed. We can calculate chi-square here, letting Excel do that. We found our p-value using that Daniel Soper website that I like to use sometimes. A little bit different from other ways we can do that, but there again, it gives you the values we need, it gives you the answers you need, and it gives you the conclusion you need. So there you have it. There's your MyStatLab Problem 9 example. I'm out.